going to give you a brief introduction to horizontal asymptotes and show you an algorithm of what to do to find them, if they're there. Because sometimes a rational function does not have a horizontal asymptote. And if it does, it's only going to be one. Now, looking at these three examples, I actually wanted to show you what will happen. So I just typed them in Desmos, and I'm going to show you the graph of each one. Let's take a look at the first one. When you talk about horizontal asymptotes, these are horizontal lines, right? And the graph should approach a certain value, get closer and closer to a certain value as x goes to either positive infinity or negative infinity. So if you're moving this way, what is happening to the graph? Do you see how the graph is basically becoming zero? Like it's not, it doesn't actually reach zero, but it gets very, very close. And on the other side also, right? If you go this way, your x is also basically zero, right? So here we definitely will have an asymptote, and that's going to have an equation y equals zero, which is the x-axis. Okay, that's called the asymptote. Okay, now let me take a look at the second one. What's happening with this guy? Okay, so again, we're looking at what happens for large values of x. Let me try to get close to it. So you can see if you're moving this way, right? What is happening? It looks like the y value gets closer and closer to what? Well, I can go ahead and draw this. This looks like it's -3, right? And also on the other side is going to be exactly the same thing, right? Exactly the same thing. This line y equals -3 is going to be the asymptote because the graph is going to get very close to it but never actually reach it. Okay, now let's see what happens with this last one. Okay, what's happening here? It doesn't look like the graph is approaching a certain value, like after a certain large value of x, it just kind of stays about the same. That's not happening here. It just keeps going up and up and up and up, right? This is a situation where a graph actually has a slanted asymptote, which we're not going to cover in this video. But in terms of horizontal ones, we're just not going to have anything. Okay, how do you know that without the picture? Here is how. So let's look at each of these examples, and very quickly we're going to see how to tell. Okay, so the first thing you do is you drop all the other terms except the leading one, because the terms at infinity that matter are the ones that have the largest power. It's like million squared is much more important than just a pure million, or billion cubed is much more important than some 2 or something. And if you see here, we have something like x squared divided by -5x cubed. Where is the larger power, on the top or on the bottom? Well, on the bottom. In fact, you can simplify this. If you subtract the powers, you're going to see that this is just going to be 1 minus 5x. So this is a way to reduce it by canceling x squared on the top and on the bottom. But you can see that the large guy is going to be on the bottom. And when you are dividing by a very large quantity, imagine 1 divided by million. What is that? Well, it's going to be 0.0000. Basically, what this is going to become is y equals 0. That's going to be the horizontal asymptote. So, in order not to think, just think this way. If the power is larger on the bottom, the whole thing is going to go to 0. And your horizontal asymptote is going to be y equals 0, because you're dividing by a large thing on the bottom. Now, what happens in the second example? Here, again, the only terms that matter are the ones with the larger power. Well, now you can see that 3 there. Okay, so we're going to only preserve them. So we're going to have 9x cubed divided by -3x cubed. And you can immediately see, oh, x cubed and x cubed is just going to cancel. And then you're going to get 9 divided by -3, which is -3. And that's going to be your asymptote, y equals -3. So when the powers are the same, get rid of all the other terms, cancel the x's on the top and on the bottom, and the ratio of the coefficients, what's called leading coefficients, is going to give you the asymptote. Just remember that if it's a horizontal asymptote, it must have an equation y equals something, because it's a horizontal line. Now, for the last example, this is where we have that slanted thing. Why is that happening? Okay, so here again, the only thing that matters is the largest powers. So you're going to get negative 9x squared divided by negative 4x. Well, one of the x's, the one on the top, can be canceled, but the other one is still going to stay there, right? And here we're going to have, forget about these two minuses, it really doesn't matter. We have something very large on the top. And if you have something very large on the top, that thing is not going to approach anything. It's not going to at some point level off and just get closer and closer to some number. It's just going to keep getting larger and larger and larger. And what that means is that you're not going to have a horizontal asymptote. To recap, if the power of the bottom is larger, that thing is going to drag the whole thing to zero. If the power of the top is larger, the whole thing will go to infinity or negative infinity, and there will be no asymptote. And if the two powers are the same, then the answer is just the ratio of the coefficients, the leading coefficients.